Okay. Hi, Subarna. So we will start the session in another 3 minutes. So I'll quickly introduce you at the start, and then we can continue with the session.
Yeah, sure.
Yeah.
Am I audible? Am I audible well?
Yeah. You're perfectly audible.
Okay.
Yeah.
Thank you.
Yeah. Okay. Welcome back, everyone. Hope you are having a good time. Just to remind you, there's a chance for you to win a copy of an ebook by Bill Schmarzo on the economics of data analytics and digital transformation. To participate in the contest, you have to create a buzz of Skillup 2021 on your social media. The greater the buzz, the greater your chances to win the book. We also have one-on-one sessions, mentoring sessions, which are going on in the lounge area. So if you want to book 15-minute slots for these mentoring sessions, you can do that. Moving on to our next speaker, we have with us now Subarna Roy, Group Manager and Principal Data Scientist at IBM. Subarna has over 17 years of experience in data science. As a senior technical leader, she has worked with some of the biggest corporations and public sector organizations to solve pressing business problems. She has helped these organizations come up with first-of-a-kind solutions that eventually turned into successful AI and ML projects. Today, she will be talking with us on the fundamentals of building effective AI and ML systems. This is a very important session considering the fact that a majority of today's data science pilots do not deliver any business outcome and fail to go into production. In this talk, Subarna will focus on the CRISP DM framework, a process model with 6 phases that describes the data science lifecycle. The talk will be followed by a Q&A session. So attendees, please feel free to drop your queries into the Q&A box or the chat box. Subarna, the screen is all yours.
Thanks, Kashyap. Thanks for the introduction. Um, so, good afternoon, everybody. I hope you are all well and in cheerful state of mind. I would like to thank Team Analytics India magazine for allowing me, giving me the opportunity to speak about data science. Today, the topic is what it takes to build successful AI ML products. So let me share my screen before I go ahead. So there has been a significant improvement in the area of AI ML process in the last 10 years. However, as per Gartner, what it said in 2019, 80% of the AI ML pilots do not go into production, which means that 80% of the models that are built in the AI ML space do not have any user. This is kind of concerning. I am sure you, as early learners of data science, you are going through lots of concepts. You are aware of the definition of AI. What is the history behind AI? What's the difference between narrow AI, broad AI? What are the different use cases under each categories? You are aware of all these things. You know supervised learning, unsupervised learning, the concepts of little bit of reinforcement learning. Either you are trying to understand or you are pretty comfortable with it. You are making an effort in learning all these things. However, so data science, you should know that it's not just about getting the data, understanding the data, and fitting the right model. There is much more to it. I will talk about how to make model a product. Model as a product. So that requires a certain line of thinking. I will give you some practical tips so that you understand what it takes to build successful AI/ML product. This will allow you to grow and thrive in your role, also to get hired. This thinking is also very important because the future of AI is quite complex. The building and deploying of AI/ML products will require certain higher order thinking. So the first point that I want to emphasize here is have a questioning mindset. Always question the rule-based mindset. That is very, very important. So when it comes to rule-based mindset, let me explain you what it is. Many of the organizations, they are thriving on rules. They basically make decisions based on rules that are driven by human intuitions, driven by expert judgment. So they are to some extent hostile towards algorithms, and here comes in. So you have to basically differentiate between the traditional programming and the machine learning. So probably some of you know the difference, but let me reiterate that. What is traditional programming and what is machine learning? In traditional programming, rules are there. Rules are applied on data and you get the answers. In machine learning, you have the answers, you have the data, and you train the machine to learn from the data and the rules are created. So let me give you an example. Let's say you have to figure out whether a person who is moving is walking or running. Okay, so you devise a rule. You say that if the person is moving at 3 kilometers per hour or less than that, that means the person is actually walking. And if that's not the case, if it is greater than 3 kilometers per hour, that means the person is running. You feed this rule to the machine. Machine, if it identifies any data on the speed of a person, then it can infer that whether that person is running or walking. Now let's think of another scenario. You have some wearable bands. You attach it to the set of people. You collect data on their heart rate, blood pressure, temperature, along with that, let's say, body temperature, blood sugar level. All those things you collect. And then you use this data to train the model, and some rules will come out. The rules will look like this. If the blood pressure is greater than X and heart rate is greater than Y and body temperature is greater than Z, then it seems that the person is running. So basically, means the machine came out with a rule. Now this rule applied on a new person. Let's say you have another person, you don't see that person. You can collect data with variable bands from that person's body, and then use that data, apply that model on that data and see what's happening. You can say without seeing him that the person is moving. Probably the person is running. Probably the person is walking. So here comes the probability. So machine learning is defined in probabilistic framework, while traditional programming is in deterministic framework. Now, let me talk about a very interesting person named Paul Mihiel. So there is a book named Thinking Fast and Slow. He appears in this book. This book is written by famous economist and Nobel Prize winner Daniel Kahneman. What Kahneman says is that Mihiel, he is a psychologist. He is a clinical psychologist. He actually came up with this theory that statistical prediction beats human prediction hands down. He has applied this statistical prediction way back in 19th century. And he got some very astonishing result, astonishing from that time point of view. So 20 of his studies showed that statistical prediction is far better than human intuition-based prediction. When this publication came out, there was shock. There was surprise that how can algorithms beat machines? Mihiel explained that humans act clever. They try to build complex models using complex features. And what happens that the mental model that they build in their head may not generalize in other contexts. While statistical models built on simple features generalize well in different contexts. So coming to this point, so whenever you are speaking to a stakeholder, trying to convince about your products, it's very important, products as well as the model, the initial time. So you need to bring out these points. You probably need to build quickly some prototype of the models and show that algorithmic prediction is far more superior than human-based prediction. Here, it is also important that you bring in the question of explainability and interpretability. Let's say you are building a fraud model and you have a feature. How many times a particular high volume transaction has happened in the last 4 days? So you have this feature, you figured out that for some of the accounts, this feature is quite significant and you tag it as fraud. Now, when you are justifying why you are calling an account fraud to your stakeholder, you bring to their notice that in the past data, 95% of the time, if this variable is significant, that account turned out to be fraud. So you are justifying, you are explaining your model to a stakeholder, and that goes a long way in adoption of models as products. Now let me go to another point. Since I have talked about rule-based traditional programming, many software development projects are based on that. So the rules are there, the data is there, and you apply the rule on the data and the answers come out. The project more or less becomes successful. There is very low chance of failure. However, in AI/ML projects, it's not so easy. It's iterative. You have to do extensive research and sometimes it can be quite uncertain. So the path towards destination is uncertain and you may go round and round without reaching the destination at any point of time. So there, what is important is taking the structured approach. This is the CRISP DM framework that I'm talking about. So the first phase of there are 5 phases there. So you have the business understanding phase, data understanding phase, then data preparation, modeling, evaluation, and deployment. I will go into each of this one by one. Business understanding consists of understanding the customer's objective, and that can be tricky. I will elaborate that in my next slides. Data understanding will consist of data exploration and experimentation. Data preparation, you will have data wrangling, manipulation activities, and feature engineering. Then comes the modeling and evaluation phase. And finally, you come to deployment. This is the time when you are really happy and feel successful that your model has been approved and the user is ready to use the model. So let me talk about understanding the objective phase. So this is a phase where the customers are given the customers are supposed to come up with the objectives. If that objective is given top down, well and good, you have to just break it down into smaller components and then gather information on each of the phases. But many a times it's not given in such a structured manner. And you have to go and find out what the pain point of the customer is. You have to go through the MIS reports, probably you have to interview the customer. So there are different methods to ask the question. Now, the first thing often the company wants to know, that is, let's say this is about building a churn model. How to lower the churn rate in our company. So the company asked this question, and if you ask a sequence of questions on top of that, you will figure out that it's not the churn rate that the company wants to minimize, but wants to maximize its revenue. And if you want to dig down a bit more, you'll find out it's not the revenue, but the profit. Because there is a cost attached to retaining every customer. Now comes the descriptive questions. There are many questions that can be asked in this phase. What was the churn rate 1 year back? Was there a significant increase in churn rate in the recent past? How many customers are we losing? Who are the customers we are losing? Is there any geographic location from where there are more churners? Did the churners complain about any particular service before they move out? So all these different questions can be asked and can be answered using descriptive statistics, like your distribution that you are learning probably and your central tendencies. So here you can actually understand the broad activities and the broad business problem based on the data. Now comes the predictive question. Can I know in advance which customers will leave? This is actually a very pertinent question in the AI/ML space because it is all about prediction in AI/ML. Now, you have the descriptive questions answered. You know what drives the churn. You come up with your own hypothesis about what actually leads to churn. So you have this hypothesis in mind. Now you create meaningful predictors, and this is a very important thing. This is where your feature engineering comes in. You create meaningful predictors. You use those predictors, and meaningful predictors are the holy grail of a good model. And these models with good predictors, but with a simple algorithm, may go a long way than difficult and complex algorithms. So asking the predictive question and creating meaningful features are the key to success of AI/ML products in the AI/ML space. And the third question that can be asked is that a kind of prescriptive question. Do I know the levers that drive the profit maximization while our retention campaigns go on? When we talk about profit, it's more of short-term in nature. It's short-term in nature, and the customers probably may game that system. So then you bring in the customer lifetime value and all those objectives in play. But the basic thing remains the same. You ask questions in different categories that will help you in articulating your objectives. And that is how your path towards the destination will be set. So asking the right business question is one of the important success criteria. Now comes the data understanding and exploration phase. And this is a phase which is quite laborious and time consuming. But believe me, if you complete this phase, you are on track. Your success is almost sure. It is certain. So first of all, you need to understand whether the objectives that have been set earlier, do you have the data for that? Many regulatory where the industries like banking and a public sector, They are regulated industries. And you may not find the data that you are looking for, because there will be certain confidentiality clause and all those things. So getting the right data is important. And if you are not getting it, you have to go back and redefine your objective. So there is an iteration in this case. You have to differentiate between the noisy signal and the real signals. If you are not able to, so one thing is that sometimes you find a signal as noisy, but turns out to be actually real, and the other way around. So you have to be very careful while choosing your signals. This is the phase when you prepare a clean exploratory analysis report. You do a lot of analysis to figure out the relationship between various predictors. Also the relationship between a predictor and the label. Coming to the label is also important. Do you have complete label data? When you are building a churn model, do you have the data of past people who have churned? So if your label is not available and it is incomplete, then you have to resort to another modeling strategy. Maybe you have to develop an unsupervised model, which you are not thinking about, and your whole story will change. You will now not predict the probability of churn of a person, but probably some anomalous behavior of a person, which might or might not lead to churn. Sometimes, if you don't have the label, you may create a proxy for that. But all these things you have to discuss with your business. Do they buy in to your proposal? So, and also it is advisable in this stage to come up with a quick prototype of the model to show what is the indicative output, so that the stakeholder is immediately, they know that what is expected from this project. The third phase, that is the data wrangling and feature engineering phase, this is also one laborious process. 80% of the data scientist time goes into this. Feature engineering is one of the most important process, and there are AutoML tools now available because of the deep learning capabilities that we have now. But I would suggest that if you have the time, you should go for handcrafted features first. It's important you know what kind of features are going into the model, because that will help you in your interpretation and explanation of the model. While AutoML features help in reducing the time, it's again some of the features probably may not be as explainable as is expected. So there is a basic difference between this automated features and handcrafted features, and you have to get careful with what features go into the model. The second thing, come up with the data wrangling plan. What are the different data sets that you want to join? What would be your joining strategy? What would be your sorting mechanism? What would be the aggregation mechanism that you want to apply? What would be your group by method? All these things would require a complete understanding of business, customer objective, and data. You need to combine all this understanding to come up with a data wrangling plan. And this can also be iterative, given the level of maturity you have in these different processes. So the fourth stage is modeling and evaluation. Now, this is a very exciting phase, and this is the phase you are looking for to come to the model. You are excited to build the model, basically. But this phase, there is also, you are basically teaching the teaching the machine to learn. So here you are teaching the machine to learn, and you yourself have to learn many things during this period. So one thing is that how to innovate. If there is a probability of failure, means if you want to, if the business is not going to accept your model, then you have to have alternate plans. So keep those plans ready. But your failure is very much managed if you have already developed a quick model in your data exploration phase. So then it's just a matter of scaling up the model, getting to expand the sampling window, adding up new features, also experimenting with new algorithms. This is the phase when you think about whether you would go for a deep learning model. Then you have to talk to your architect and understand what's the GPU configuration currently available. You want to deploy your model in cloud, you have to think of security. You have to understand what should be your strategy for hyperparameter tuning, let's say. If you are building a deep learning model, you need to know what would be your number of input nodes, output nodes, what would be the different hidden layers. So if you are building a first generation model, let's say, first generation model means that the customer will be using a model for the first time. Then it is advisable to keep it simple and keep it explainable, interpretable. That is very important. Even if you give a certain amount of accuracy, that's okay. If you are going for a second generation model, that is, your model is going to replace an earlier model, then you have to think, of course, about how to beat the accuracy, precision, or recall, whatever be the evaluation metric in that case. However, don't give up on the explainability part, because that is important. If you want to showcase how much business benefit the model is generating, that you should do always. If you're building a fraud model, figure out what is the amount of fraud dollars that the model is saving by targeting X% of the high scoring population. Some of the models will not have direct business benefit. Then you have to sit with the business to understand what should be the acceptance criteria. Make your model forward-looking. If your model is going to be deployed in a geography where there is a crisis impending, be aware of that and estimate that, factor in that in your model. Even if the model loses its validity in the current period, it should remain relevant for the future. So the next phase is about deployment and monitoring. This is the phase, again, I would say that you should be happy about, because you have come to this phase. You have got a sign off on your models from the stakeholders. They have approved. They have given a green light now to deploy the model. So now it is a phase when you will be transitioning your model pipelines and deployment pipelines to the data engineering team. So during this phase, you have to collaborate closely with the data engineering team. You share your environment configuration and ensure if the deployment is happening in a different environment, ensure that the results in the modeling environment and deployment environment are matching. You will get a lot of feedback on the front end, because that is what the user will be seeing. So you will be doing a lot of tests on the user interface part, but you may not be testing your model. It is very important that you reevaluate the model as it gets exposed to lots and lots of unseen new data. And now that deployment is done, it's important that the AI products is monitored regularly. There is a monitoring team, but your role here is to create that alert framework. Alert framework where you define what should be the cutoff, below which there will be a trigger. What should be the cutoff on that evaluation metric? If it is the accuracy or the recall or the precision, if it goes below a certain level, there should be an alert, and that notification should go to you. Your job doesn't end here. Then you have to think about whether you need to redevelop the model or reweight it, and then again you have to go back to your business understanding phase, because you have to understand if there is a change in the business environment. So this is the I completed the structured approach point of view. So one more thing that you need to be aware of is that the collaboration is key to success. So you need to ensure that you are constantly talking to the business user, to the UI people, the architect, the domain expert, because if you work in a siloed workspace with no user, it's going to definitely fail. I can talk about my experience. I was developing a model in predictive maintenance space, and the model was giving good accuracy. The stakeholders were quite happy about the level of accuracy that we were giving. However, it was not moving forward. The project was stuck at the pilot stage. Only when the field engineers, who are the actual users of the model, they got involved, the operationalization of the model, conversation on that started. So it's important that even if it is not in your hand, but you voice your opinion about bringing in other people as collaborators. So that's key to your success. Another thing that is very, very important, and nowadays there is a lot of discussion going on in this space, is how to develop models using unbiased approach. And that is one factor that can impact the acceptance of a model. So when you are developing a model, let's say a model that is going to recommend about the recruiting strategy. So if that model has gender or race as predictors, that model is inherently biased. So that model is unacceptable. So you have to ensure that even a feature which is not correlated with that model, you need to ensure that that doesn't impact the recruitment strategy. So for unbiased recruitment, it is very important that you look at an unbiased approach when you are developing models. When you are developing a bot, you should remember what the bot is going to serve, whom the bot is going to serve. If there is a other side, there is a human, it's important that the human should know that there is a bot it's not a human being. It's basically if you develop a bot which is not perfect, that is fine, but transparency is the key. The human should know what the bot can do and cannot do. Also, there should be abuse handling strategy that should be there when you are developing bot. When I was developing credit scoring models for US geography, there were strict guidelines that we should not use demographic factors because that would bias the model. So bias in model development is also an important factor in your model and getting an approval for the model. So I have discussed some of the key points that would enable you to develop meaningful AI ML products. If your basics are right and you combine your knowledge with the basics, I'm sure you will be very, very strong in your area of data science. With this, I come to the end. If there is any question, kindly let me know. I will be happy to answer. Over to you, Kashyap.
Yes, thank you, Subarna. Actually, we just have 2 minutes, but we can take this one question which has been asked. So the Kaustubh is asking, how did you become a data scientist? He is very curious to know that. So if you can answer that in the next 2 minutes, we are safe then.
Okay. So for me, means my primary education is in application of econometrics and game theory. I have done PhD in that. So I was from the very beginning during my academics also, I was working on data to get meaningful insights. Even in my research, I have used algorithms, statistical algorithms. So naturally, I was recruited as that time it was not data scientist when I joined HSBC. I joined in the statistical modeling team. That then over the years, I also learned concepts of machine learning and deep learning, because statistics and mathematics are anyway the base of it. Okay. Yeah. So that way I moved to data science.
Okay.
Yeah.
Thank you so much for that answer. And thank you so much, Subarna, for your time. I'm very sure this was a very insightful session, and I hope data science models can get more and more accepted rather than just sitting on the shelves after this session. Thanks again for your time.
Thank you. Thanks everybody for hearing me. Thank you.
Yes. Yes.